This video goes over how Maple solves boundary value problems of ODEs. It requires you to learn two complicated and difficult to comprehend procedures. Just kidding. Let's get started. I begin by reminding you about initial value problems. This is where we have an ODE and we want a single solution, not a family of solutions. In order to get the single solution, we need to come up with a number of constraints equivalent to the order of the ODEs. So if we have a second order differential equation, then we need not only the function, but we also need the first derivative. And for an initial value problem, this is at a single location or a single point in time. For a boundary value problem, we have information at one location or one point in time and another location or another point in time. In this example, I know the value at this location and I know the slope of this function at that location. So here's our function that I've sort of drawn, and we have two boundary value equations that y at a is equal to 2 and y prime at b is equal to minus 1. These are the two locations, 0 and 2 pi. How do we solve this problem using Maple? No, you don't have to use a complicated new procedure. You use the same procedure you used to. Desolve, curly bracket, ODE, comma, the boundary value equations, close curly bracket, close parentheses, and there is your closed form solution. We can then make a function from it, y equals make function, by evaluating what y of x is from our solutions. And this is a function of x. And then we can plot both y of x and y prime of x from x equals a to b. And we'll be in a legend of that we have, quote, y of x as our first element, and then back quote y prime of x, back quote, close square bracket, close, and now we have both on the same plot. Can Maple solve boundary value problems numerically? You bet it can. So here we go. Here is our ODE. These are our boundary value constraints, and these are the endpoints, the boundaries themselves. How do I solve it? Well, let's just check to see if we can get a closed form solution. And as you can see, it's a huge mess, and the answer is no, unless you want to include the integral. So what do? We include desolve, curly bracket, ODE, BVES, close curly bracket, comma, numeric, and as always, output equals list procedure, close. And now we have solutions for both the y of x and the first derivative. Let's take the results and plot them. Y equals evaluate what y of x is from our solutions. And y prime, we will evaluate what y prime of x is from our solutions. And now we will plot on the same plot y of x and y prime of x, close square bracket, where x goes from a to b. And we'll again add this legend in. Legend equals open square bracket, single quote y of x, end single quote, single back quote y prime of x, single back quote, close parentheses, hit enter, and there's our function. And again, it shows the legend as y prime. This last part is mostly an aside to make us think about how Maple might solve some of these problems numerically. And it basically starts by using the initial value problem and then using a parameter to satisfy the both boundary value conditions. So let's say I've created this ODE here, right there, and I have my boundary value conditions, y of 0 equals 0 and y of 1 equals 0. We try to solve for it, find a closed form solution, no luck there. So again, we use the numerical procedures and we extract them and we plot them. And as you can see, does match the conditions of y of 0 is 0, and y at 1 is 0. So instead of trying to solve for the two boundary value problems immediately, we're going to actually start with the initial condition of y of 0 equals 0 and some guess for the initial slope, and hope that after an evolution of space or time, it will end up at the right spot. So I'm going to redo this problem, but now I'm going to give it initial conditions, y of 0, 0, and y prime of 0 is some constant, some parameter. We'll do a desolved numerical, including the parameter c. We will extract out our solution, and here is where the fun part is. We build a plot procedure for which we're going to pass it different values of c, have it change that value of c to a number, and then replot our guess solution. The advantage of that is that we can therefore use an explorer function, and we can vary the value of c, i.e. vary that initial slope, and find the value for which we match both boundary value conditions. Well, I hope your head did not explode after trying to understand how to solve boundary value problems using Maple. As always, the document associated with this video has more information and more examples in it.